Hey, good people. Welcome back to the last video on the ratio test. We're going to do number 5 here, and then we'll pick some from the practice on the bottom of the page to kind of get a little bit more practice and maybe an application problem. Application meaning we're using the ratio test, but the question is asked a little bit differently. But for number 5, we're just looking for the convergence or divergence of this series. So let's do the ratio test. Why would I use the ratio test on this one? I notice that there's a factorial. So chances are the factorial is going to require me to use a ratio test. So wherever you see a variable, we're going to put n plus 1. So be careful. I'm going to replace n with n plus 1. But all of this was inside parentheses and factorialized. That's not really a word, but we were taking the factorial of all of that. Divided by n plus 1 to the fifth power. This is the n plus 1th term. And I'm going to divide that by the nth term, but I don't have enough space here, so I'm just going to say multiply by its reciprocal. So I'm going to multiply by the reciprocal of this, which is n to the fifth, over 2n quantity factorial. Alrighty. As I rewrite it to kind of get a better view of what I'm dealing with, I realize that in this numerator, I'm doubling n plus 1, so that's really 2n plus 2. So I have 2n plus 2 factorial. But 2n plus 2 factorial is 2n plus 2 times 2n plus 1 times 2n plus 0, which is just 2n, times 2n minus 1 times 2n minus 2 times 2n minus 3, all the way down to 1. So from here on out, I can say, hey, this goes to a factorial times n to the fifth in the numerator. All of this divided by n plus 1, not n plus 5, n plus 1 to the fifth times 2 to the 2n factorial. Well, what do we notice that we can reduce? Hey, look, the factorial here and here is gone. So now all I need to do is take the limit of the leftover. But when I look at the limit of the leftover, if I were to multiply all the three terms that I'm multiplying in the numerator, the largest term would be 4n to the 7th. Now, there would be other stuff, but that would be the largest term. And the biggest term in the numerator would be n to the 5th. Now, there would be other terms, but that's the largest one, n plus 5th. Well, if I were to take the limit as n approaches infinity, the numerator is growing at a faster rate than the denominator. So therefore, this limit goes to infinity. That is definitely greater than 1, and so it's going to diverge. So the series right here diverges because of the ratio test. Because when I took the limit, my limit was bigger than 1. It was actually infinity, and so therefore I am able to say with certainty that the series will diverge. This is the ratio test. Take the n plus 1th term and divide it by the nth term. Or, if it's already a fraction, take the nth plus 1th term and multiply by the reciprocal of the original setup. Okay, let's do one of these bottom problems here, and then we might be done. I feel like number 2 is pretty straightforward. Same thing with number 3, but I guess I could do number 3. Let's just do number 3 quickly. The limit as n approaches infinity of n plus 1, the absolute value of n plus 1 plus 1, right? Because I have to replace this n with n plus 1 and then plus 1 times 3 to the n plus 1, all divided by n plus 1 factorial, times the reciprocal of that, which would be n factorial over n plus 1 times 3 to the n. And we're taking the absolute value of this. Well, that's going to equal the absolute value of, let's see, what are we dealing with? This is really n plus 2. This is 3 to the n times 3 to the 1 times n factorial. In the denominator, I have n plus 1 factorial. N plus 1 factorial is n plus 1 times n factorial times n plus 1 times 3 to the n. Can I cancel, reduce anything? Heck yeah. Those two are gone. Those two are gone. And I think that's it. So we are left with 3 times n plus 2. In the denominator, I'm left with n plus 1 times n plus 1. So if you think about it, the biggest term in the numerator is 3n plus 6. I guess if you want something else, the biggest term in the denominator is n squared plus other stuff. So this is a bottom heavy situation. As I take the limit as n approaches infinity, the denominator is going to grow faster. So the limit value here is equal to 0, which is less than 1, and therefore it converges. So this is a convergent series. I know that by using the ratio test. Alrighty. I wanted to do one of these two, and I'm not sure which one. I kind of want to do number 3 because it involves a series that has n's and x's. So the question is, for what are values of x greater than 0 for which the series blah, 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 blah converges? Well, let's use the ratio test. Take the limit as n approaches infinity of the absolute value of, and then let's plug in n plus 1 times 6 to the n plus 1. Why don't I just write it now as 6 to the n times 6 to the 1 divided by x to the n plus 1, which again I can write as x to the n times x to the 1. And then we're going to multiply by the reciprocal, which is x to the n over n times 6 to the n. Take the absolute value of that. Now wait, when I find this limit, I want it to be less than 1 because I want it to converge. So I'm going to set this limit to be less than 1 so that it does converge. I can reduce this and this. I can reduce this and this. So what's left? The limit as n approaches infinity of the absolute value of n plus 1 times 6 over n times x. Now, why did I switch the roles here? Because I wanted you to see the limit only affects n variables, not x variables. So when I take the limit of this, really, I'm just taking the limit of this, which is 1, and that leaves me with 6 over x, and 6 over x has to be less than 1. Now, I still have these absolute values, right? But remember, they told me the values of x are always positive for x's that are greater than 0. So I don't need the absolute values because I know my x values are always positive. And I can set that less than 1. And now I can just solve. Multiply both sides by x. So x's that are greater than 6, for any x values that are greater than 6, we will have a convergent series. So think about what you just did. This is a series where n's are changing according to this counter, but x is a variable. But if you use x values that are bigger than 6, you can be assured that that series will converge. This is now getting into the territory that we're heading after this section, where we're going to have to deal with power series and series that involve x in the formula. This is the last video for ratio test. We'll come back, we'll do the alternating series test, and then we'll be ready to jump into those power series that I just alluded to.